All right, everyone. Welcome to this week's presentation. We're going to be dealing with a bunch of little or smaller topics that actually are a big issue in cars today. Lighting, instrumentation, and the navigation systems we'll be looking at this week. And some of the objectives that we'll be trying to deal with will be explaining the operation of a typical headlamp switch that many of you are familiar with and comparing the different headlight designs that are out there. We're going to summarize some of the lamp delay and auto dimming systems that are out there. We want to be able to explain the brake, backup, turn light, and light failure circuit operations that are very popular today. We're going to summarize the operation of some of these bimetal and magnetic coil gauges that we'd see on our cars. We're going to explain the operation of the speedometer, the temperature, the fuel, and the oil pressure gauge circuits. We're going to compare conventional and digital instrumentation systems. And then we're going to summarize the operation of some of the voice alert and recognition systems that are now becoming almost popular in every car, and summarize the operation and construction of the navigation systems. So let's start out here. First, we got lights, right? And this is energy from electromagnetic radiation and travels at a speed of 186, 282 miles per second. I actually measured it to verify that. Just so you know, you get some context around this. The theories of light deal with the movement of electromagnetic waves through space, the movement of photons through space, that you may learn about some of your science classes that you're going to take here at Southwestern in more detail. The type of light bulbs that we deal with, we're looking at incandescent light bulbs. The halogen light bulbs are very popular. Very common today, the HID, high intensity discharge light bulbs. We also have those neon light bulbs that are out there. And very common today are light emitting diode systems. You will also see that we're going to look at the headlight switch. We're going to talk about the combination headlight switch, the dimmer switch, headlamp bulbs. And we were already seeing that last week with a couple of vehicles that we were looking at, just some of the combinations that are included in one switch. It's sometimes pretty amazing how many different functions they can get into one switch. We're going to look at sealed beam headlamps and then conventional lamps that have a filament that are enclosed in a vacuum sealed glass housing. We've got a halogen headlamp insert. Those are more common today, that increase the output by 25% with no increase in current draw. That's right, no more amps. Whiter light than conventional bulbs and rated in watts. The federal regulation limit for these, the low beam output has to be held at 20,000 candle power is how we measure that. With the halogen bulbs, you're usually dealing with an insert, and if you look here, every one of them will have some kind of lock. Different manufacturers will lock these or secure them in place differently. Very common to see these broken, which will lead to humidity issues inside the light bulb where you get that fogging and so forth. And there are different styles of these bulbs that are out there that are available for us. And then the other style we have are the high intensity discharge bulbs. And those are electrical arc that excites a xenon vapor in a bulb. And they have an external ballast that converts battery voltage into high voltage AC voltage. And the startup voltage is several thousand volts on these systems. And we have to be extremely careful when we're handling these HID systems. They're high voltages. There's a lot of pressure in the bulbs. They can explode. They can be dangerous, especially with your eyes. So keep in mind, right, whenever you're dealing with these systems, there's a high initial startup voltage in an HID system. And you want to make sure that you're using, some cautionary measures to protect from electrical shock. Also, HID bulbs are under high pressure when they're hot, so creating an explosion. You got to be careful with these, taking them out, especially if they've just been lit, and never operate an HID bulb that has been removed from a headlight assembly, because if it shatters, those little pieces of glass will fly everywhere. We do have some vehicles that have these retractable style headlamps themselves, which doesn't necessarily have anything to do with the bulbs themselves, but they are designed for increased aerodynamics, which in turn result in what? Yeah, better fuel economy. Some of these are operated via vacuum. Many of them are operated by the more traditional electronic or electric motor system that allows them to flip up, flip down. Think Corvette style headlights here in this case, although there's others. The auto lamp system, here's kind of the circuit build out of that. Again, we got our fuses up top, we got a circuit breaker involved, and then we have some kind of auto lamp relay that's in there that's going to control those lights to be turned on. And then depending on how the system's set up, it could be that it detects lack of light, ambient light outside, that turns these on. It could also be systems that are doing the high-low beams when we're passing vehicles on the street. Then we have the turn, emergency, and stop lamp systems. These are all separate systems. Keep in mind, they use the same wiring connections and light bulb styles, but they are separate, individual from those main headlight systems. Many of these systems are using those smaller incandescent bulbs. They might have one or two actual heating elements. You can think of these, maybe even like the stoplights, right? That'll be one bulb with two filaments in it in most cases. So lots of variations here with this system as well. All right, and when we're looking at the turn signal system, just keep in mind some of the main components that would be involved. We're going to have some kind of fuse on every circuit. We got a turn light switch that's going to indicate the direction we want to go. There's what they call a flasher unit, and then there's going to be light bulbs outside that indicate the direction that we want to turn, sometimes LEDs. And then we have the indicator bulb inside the car, verifying what we want, the wiring, of course, and then usually part of a multifunction switch. This multifunction switch is very often found in the steering column, and these have gotten more complex over the years, but you can see all these little switches have to be kind of jammed into this small area. We got turn signals and horns, hazard lights in some cases. We've got the windshield wiper switch on there. A lot of stuff going on in this area, and it's critical that we're careful when we're working in this area, just due to all the wiring that's there so that we don't inadvertently damage anything. Then we have the emergency flasher system. This is also called the hazard warning system. It's usually a push-pull switch, although there's variations of this, toggle switches. And then this system is designed to open and close circuits to the lights. And obviously, by definition of emergency, these are the ones that are flashing alongside the road to indicate that there's a problem and try to help people hopefully avoid us that might be on the road or see us before they get too close. Our stop lamp system is also referred to as our brake light system. Again, you'll notice that there's some common strings here. Again, we're going to have a fuse. We got to have some kind of switch. In this case, there'll be a brake light switch, which is actually usually rather special on the vehicle. It's actually two switches in one. And then we'll typically have two rear lamps, and even most vehicles have a high mounted lamp as well. And then again, the wiring that brings all of this together to actually work. Other light systems that we'll be looking at or talking about this week will be the brake warning light system that's out there when we have a failure, backup light system. There's the interior light system that's gotten very fancy on many vehicles. And then, of course, our light failure system, right? We have a bulb go out to give us an indication. Otherwise, we'd be driving around unknowingly that that we might have some brake light not working or some turn signal could lead to an accident. On the backup light circuit, you'll see here that we have some switches on the transaxle. We have the engine firewall, the front dash, and the ignition switch all tied into this, coming through a fuse box that when we actually put the vehicle into reverse, we would send a current to those, usually those white lights right in the back of the vehicle. Now, if you've ever wondered what's in behind some of those gauges, for example, let's take a look at this one. We got a magnetic coil gauge here. This style would be, very common with the fuel system. It's got a low coil and a high coil that has a voltage source, and then you have two grounds that are involved here. And then these create a magnetic field based on the inputs that are being sent to them to pull that sensor one way or the other based on the fuel level sensor. Now, we also have the bimetal gauges that are behind the dashes in some cases. These are usually consistent with temperature gauges. They'll have some kind of voltage regulator that maintains a constant voltage to the system, and then it goes out to some kind of bimetal bimetallic strip of some sort. No current here, and it doesn't load or bend the strip itself, but causes that gauge to fluctuate from low to high. And you can see that wired up here on a temperature gauge circuit, where you would have that thermistor sending unit that's sending a signal to the bimetal arm with that coil. And as current heats up the coil, obviously the more current, the hotter it would get. It causes this gauge to move. So it starts from a very low temperature, a very low current flowing, and then all the way up as current flows, it gets hotter, and that gauge would start to move at that point. Now, on this fuel gauge circuit, we also have some variations here as well, and we can use that variable resistor in that tank on some kind of float that signals a bimetal arm inside that gauge as well. And then depending on that float level sensor, well, we can change the resistances, which in turn will change the current values and then cause the heating of that coil to vary, which in turn will give us some kind of reading back to our instrument cluster. There. You'll also notice that we have fuel consumption indicators on there, and these typically are indicating the average fuel consumption that you get when you're driving the vehicle. You may have seen this on your car, telling you you're getting 16, 18, 25 miles to the gallon, depending on how you're driving. And then also, you may have miles to empty, not always 100% accurate. And the main input devices are the speed sensor and the fuel sensor. So how fast we're traveling and how much fuel we have left in the car. And then they take in some other factors as well on some vehicles. The fuel consumption indicator diagram here, see again, we have a fuel power source through a fuse block. It's feeding that fuel gauge sender and then feeding our instrument cluster. And then we have an engine speed sensor that's feeding into this, as well as the fuel gauge sensor. In turn, this all feeds over to the instrument panel, and depending on where this output is located, you'd see it in the dash or the instrument panel itself. Part of this fuel gauge may be and should be on almost all vehicles that I can think of have a low fuel warning light. Usually this is a good time to start looking for gas, but in this system you can see there's a lamp that's triggered once that fuel gauge gets low enough, usually triggered off of the fuel sending unit as well, to let this thing know, hey, there's low fuel in the vehicle, and then of course have the lamp light up in the dash. Now, the voltmeter on the car is not much different than the voltmeters that you've been using in class, although it's a simplified version. This checks the output of the charging system, and there's various styles of this gauge, but usually we're looking for a normal operating voltage of 13 to 15 volts while the engine's running. And the problem with this is battery voltage is only with the engine running. So it's not a great voltmeter to tell you what it is when you're starting it up, especially if it's just a light. Here's a diagram of what that might look like, the voltmeter in the dash, and then of course it's sensing once the ignition is turned on, and just looking at the voltage once the starter has been engaged to look at it, sampling that line off of that starter circuit, which is also, if you remember, part of, or often part of, the actual charging circuit itself. So that's how that light would light up. Then we have the oil pressure gauge circuit, and on the oil pressure gauge circuit, again, we have a power being fed to this, and then a wire that's actually coming off of the oil pressure sensor itself in most cases. Or it could be triggered where the oil pressure sensor is sent to the ECM, and the ECM is then tied in to activate the oil pressure gauge if it determines there's a problem. And that's very common on the newer vehicles. They run all this stuff through the ECM. The oil level indicator circuit has there's a sensor down in the oil pan, and then of course the indicator light, and then what they call a delay or timing circuit. And the reason for the timing circuit on it is that the oil can splash around. So at points it may indicate that it's low if you're turning a corner and you don't want that light on. So it does take some time to trigger the light, which isn't always the best thing. Tachometer on the car is that one that's telling you the engine RPM, again wired in for power off of the ignition switch, and it usually is using a pickup off of the ignition coil in most cases, or in some situations it uses the crankshaft position sensor that feeds that tachometer to tell you what that engine RPM. Most newer vehicles, you'd see this signal being generated by the crankshaft position sensor. And then as far as the instrument cluster goes itself, usually there's a visor or lens that covers a panel or the actual face that contains the instrument housing. It's usually a printed circuit. It usually will have a voltage regulator in it, and then it'll have whatever gauges and indicators the manufacturers have deemed necessary. Now, some of this has led to some fancier instrumentation, although I'm starting to see a trend going back to the old analog style sensors we just looked at. When looking at the instrument clusters, there's three main styles that are out there. There's the analog style, which would have like needles that are swung left to right. There's the digital, which most of you are probably most familiar with. And then there are combinations of the two, analog and digital clusters. And the variations in these that are out there are just mostly on preference, and then some of it's related to dependability that we'll talk about. Now, on the rear of the instrument cluster, many of them have some replaceable bulbs for some of the warning lights that are there. There is also some kind of printed circuit board with these instrument cluster. That's how they run the wiring, on that printed board on the back end of here for all of the circuits. On some of the older stuff, especially the analog stuff, most of these bulbs are replaceable. On a lot of the digital stuff today, not so much, maybe a few of the bulbs. Now, the instrument panel wiring connects the power to all of the dash mounted devices. And that panel wiring is usually pretty complex, especially if you got to remove a dashboard of some sort. So it's always a good idea to reference the service manual, because with the service manual, you'll be able to at least get some of the major points to have some understanding when you're taking it apart. The biggest part is you got to put it back together, and you have to route those wires correctly. Looking at one of these service terminals, you can actually locate all of the different connections that are behind that dash, or at least have a general idea where to find them. And trust me, sometimes the pictures look much easier than actually finding some of these, but they all have a number and they give you some pins, and that can help you identify which one is which, because often they look very similar to each other. So it's hard to determine which one is actually, C701. Now, for the speedometer in the engine tach, especially for the speedometer, some of these dashes have a cable-driven speedometer, and those you'll have to remove the dash slightly to access the speedometer to either unthread it or retract it out. Most of the newer stuff is using an electronic speedometer that's getting a signal to it, and usually in some of these cases you're starting to see digital speedometers. Now, the digital instrumentation cluster came about because it's a computer-driven display. It's very easy to read, it's lightweight, and most of all, especially if we don't push or press on that LCD, it's very dependable. Most people actually prefer it. It gives you that fluid look, much like a heads-up style like laptop or some kind of unit that you use at home. Now, in addition to that, the digital dash display circuit diagram shows you here we have a power control module involved. You're going to notice on the left-hand side we got this CAN high and CAN low and a bunch of stuff that's wired into the instrument cluster. And that's right, the instrument cluster actually is a control unit of some sort on almost every vehicle today. And you'll notice on there that the gauge control module has what they call F-CAN transmission and B-CAN transceivers. And we're going to talk more about CAN systems in the future, but it's important that you understand it receives signals from vehicle sensors, the DAS switches, other ECMs, and then it's shared along these complex networks. And there's different ones. There's these multiplex integrated control styles. There's the body control area network, which controls like the seat movement inside the car. And then there's what they call fast control area networks, sometimes referred to as FCAN. And there's other names depending on the manufacturer. Now, with the instrumentation switches, these are triggered by the ECM to an output signal. They trigger the ECM and say, hey, we need some kind of output to happen. all switches have a constant reference voltage signal. And then when we use those switches, we are using it to drop voltage across a resistor. And that's what gives us the different inputs, how the control unit understands what it is that we're requesting. So when we go to look at one of these, like here, the dash button or the switch wiring, you'll notice that different push buttons, whether it's F1 or F2, are got different resistors involved. And depending on when you push the button would determine which path that electricity or current, the voltage would flow through, and we'd have a voltage drop. Well, the control unit looks at that voltage drop, and to it signals something specific. Maybe you want the rear window to go down, and it's got a certain voltage resistance to it. Now, some cars are actually using a monitor. So I know everyone here has probably seen the new Teslas. They only have one big display in there. These are the LCD displays. Some of them even have plasma screens. And this is used as the main monitor controller of the vehicle. These can actually operate as an actual touchscreen switch as well to activate different things. And how does it do that? You got it. It's using those networks to communicate over it, telling it with using bit form, and giving it a series of zeros and ones to tell it what it is you're actually asking for. So many of our newer cars are starting to come out with these heads-up display or HUD models. And this reflects information onto the windshield, typically maybe directional or speed information. It's semi-transparent. In most cases, the way that it's angled in the glass, you are not able to see it. But what it really is a piece of film that's actually pressed in between the glass. That reflects the image that's being projected on it. It complements the conventional displays, and what it's trying to do is keep our eyes on the road. Some vehicles have this video display. And these are cameras. Many of them are having this part of what they call ADAS. And these display images in front of the vehicle. They have infrared cameras to provide night vision. Many computer systems that are using this are actually have some recognition in them. So they'll recognize animals versus pedestrians. Very high-tech stuff. And again, part of this ADAS group of new equipment, which stands for Adaptive Driver Assistance Systems. We also have the voice alert system in the vehicles. These are electronic circuit that drives the speaker. It alerts the driver if something's wrong. In most cases, you would probably be most familiar with this with navigation in your vehicle. When you're driving around, maybe it's telling you without taking your eyes off of the road to make a left or a right-hand turn or where to stop or what you're looking for. Now, in addition to these voice alert systems, we have a much more high-tech version with the voice-activated systems. And this has seen some very significant upgrades over the years. This reacts to the spoken word. They have pre-programmed words that it's told to do, like, call, home or call my wife or something like that. It's programmable by the user, and many of these systems are actually programmed to learn of the user himself or herself that's driving the vehicle so that the voice recognition is accurate. Now, as far as navigation systems go, this is using GPS to calculate the vehicle's position. We need to have at least 3 GPS satellites to do this triangulation of where the vehicle is located. There's another function that's called dead reckoning. This would be if we were going between mountains, buildings, the city, or tunnels that can kind of predict where we are. But to get an exact location, we need to have 3 of those satellites. And then finally on this, those GPS systems are often tied into vehicle tracking systems that are on the car. And this can track the vehicle if it's stolen. There's some components that are in there. There's a security control module. It usually has a separate cellular number. It uses GPS. They have 24-hour monitoring systems. And some have these emergency call systems. You guys are probably familiar with OnStar. The most interesting part about this is that many of the police departments have actually started to integrate these systems into their actual daily function so that they can track cars if they need to. Now, again, guys, if you have any questions, this is a brief overview of any of that. There's a lot of details to some of these systems that would require much greater in-depth analysis. But I think this is a good starting point for everyone. So if you have any questions, once again, please make sure that you reach out and ask me. Always willing to try try to help out and clarify any of these systems that I can. All right. Thanks a lot, guys, for watching, and I'll see you next time.